Hello everyone. Today I'm going to introduce my project, which called VR4ALL. So this is the project we are trying to build for an educational toolkit for VR learners. So before we talk about what is VR4ALL, I want to talk about the overall goal for this. We really want to break the VR black box for students. So to achieve that goal, we have three. I really want to make it like the three properties here. First, I want to make it affordable for students, which means that the whole toolkit for this VR development kit will be less than $100. Second, it's like instructive. So I want to cover both VR hardware and software knowledge in a decent amount, rather than over covering the part of them. Also, but at the same time, I want to make it friendly to beginners without much low-level details to figure out, like for example, like the low-level hardware, like programming stuff. And also for a progressive milestone achievement so the student can follow it easier. Third property I want to make is extendable, which means that it could be a platform that is capable to extend to further advanced features, such as customized rendering pipeline, more computer vision tasks, eye tracking, AI voice assistant, etc. So how do we achieve this? So this is a VR4 solutions I try to build. So the whole toolkit components including 5 parts. First is a mini computer. I choose the label potato. Second is a display, which could fit into such VR cardboard side. And also, this should be a really high resolution part. Third is optics, which could view the VR stuff, put the VR screen far away to make people feel that it is perceived in the real world. Also, we need an inertial measurement unit, which is IMU, to tracking for the eye rotation and position. Finally, I want like the ESP32 camera module to extend to more advanced computer vision, pose tracking, and hand gesture recognition tasks. So to go to our current position, this is the current Gantt chart we have. So there will be 6 milestones for now, and we are currently at the milestone for the first step, which is we want the rendering and correct stable rendering for WebGL, which currently goes pretty far. The sourcing list here is an initial plan. As you can see, the total like unit price for them is like $143. This amount could be further reduced to $100 by first like we could further like do without like HDMI board version, which could cost like less than $32. And this is doable by directly using a MIPI connector to this. And also, I want a less powerful liberal stuff. Probably could also save another $10 and for the bulk price. So the overall, the system could be built less than $100. So this is the result I do for the market search. For the target population, there could be some like students who study VR stuff like CS, CEE students, and hobbyists. And also universities could pay or are interested in building such course. This product could also be helpful for them. And also the VR related tech, VR tech related companies, such like some technologies about like the eye tracking, hand tracking, like this could be a very good collaboration with them. So list of competitor, I really don't really hard for me to find some like similar stuff on the website, but there are 2 things I want to compare here. First is a VR web course from the MIT. It is like cost you like $2,060 per student, and this only teaches software programming, which for our development kit, we can teach both the hardware and software. On the hardware side, there's another company called Invention XR, which is serves for providing the VR hardware for probably a 20 people class. It will cost like $7,000, which only teach about the hardware part. So this course will really change the game by combining both the VR and like VR hardware and software together. So I want to also talk about some experience when I'm doing this project for so far. So how people think about the technical or usability of the work. Some people do provide some suggestion that probably for a hardware course, probably picking a mini computer is a little bit like too high level for them. But my understanding is we want to first make it really extendable, which means that we want to build this stuff by having more functions. So if we do the whole stuff in a system on chip options, this like the hardware memory, they will be so customized and hard to extend. One new thing I learned so far, I think the most important thing is what is the pipeline for building a VR stuff and how to set it up. I think this stuff is kind of like a secret um, for like teaching such kind of like knowledge. But I'm very lucky that during some research, I finally figured it out with such current solution. And useful piece of information for the rest of class, I think I really want to introduce about if you're the students or rest of class interested about like how to render and graphics things using WebGL, I can definitely share this later. But before I go to the screen sharing stuff, I really want to make an advertisement here. So if you're interested in such stuff, there's already a summer course called CS396, which called like Advanced Graphics Seminar VR System taught by me in this summer. So if you're interested in this content, learning about both the VR hardware and software, feel free. I'm very happy to feel free to reach out. I'm very happy to help you. And you can of course take that course to learn more about that. So now I will go to the sharing for the WebGL rendering stuff. So first I want to show you like what the things for currently for now look like. So this is a stereo things, and if you can use the mouse to control the 3D thing, and you can see there's a vignetting mask simulated for the VR vignetting effect if you're looking to such lenses. To do this, this is achieved by we using the 3GS. So the 3GS pipeline to do this, there are several parts for setting up the GS server. After you set up the GS server and library, there are several things. Key part we need to like clarify. First, what is the renderer? And the renderer, the target, the camera, basically your control for your navigation, what is your geometry, what is your thing for you're gonna render, and what is the composer. Composer here is very important to rendering the post-processing effect, such as the vignetting mask. So after combine all of these stuff, I think for me, for next step is how to correctly set up the camera for the two eyes. But so far, this is what we have achieved for now. So yeah, that's all. Thanks for listening.